Hello students! Welcome back to our science video. For today, we will discuss another type of a chemical bond which is covalent bonding. At the end of this lesson, learners are expected to demonstrate how atoms bond with one another using the Lewis electron dot structure and explain the formation of covalent compounds. Covalent bonding is a bond between a nonmetal and another nonmetal. It is formed when atoms are held together by sharing electrons. Before we begin with the bond formation, let's enumerate some of the properties of covalent compounds. First is boiling point and melting point. Covalent compounds have lower boiling and melting points compared to ionic compounds. This is why most covalent compounds are liquids or gases at room temperature. Examples are liquid bromine and chlorine gas. Another property of covalent compound is conductivity. An exception to this is graphite. Graphite is a good conductor of electricity due to the localized electrons in the structure, which allows the movement of electrons. As you can see in the picture, layers of graphene contain the localized electrons that can conduct electricity. Next property is hardness. Diamond, the hardest natural substance, is a covalent solid made up of purely carbon atoms. In its three-dimensional structure, the carbon atoms are linked to four other carbon atoms. On the other hand, other covalent solids like gelatin and low-density plastics are soft. The last property is solubility. Covalent compounds vary in solubility depending on the polarity, like dissolves like. Non-polar compounds are soluble in organic solvents but insoluble in water. For example, naphthalene is soluble in toluene but not in water. Polar compounds are soluble in water but insoluble in organic solvents. For example, glucose is soluble in water but not in toluene. Compounds with a central atom that has no lone pairs will be insoluble in water. Diatomic molecule is a molecule consisting of two atoms. There are 7 diatomic molecules known as super 7: nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. All of these elements are nonmetals, since the halogens are special type of nonmetallic element. Bromine is a liquid at room temperature, while the other elements all gases under ordinary conditions. As the temperature is lowered or pressure is increased, the other elements become diatomic liquids. To easily remember the 7 diatomic molecules, we can use the acronym "Have no fear of ice-cold beer." All atoms except noble gases have less than 8 electrons in their valence shell. In other words, the valence shells of these atoms do not have stable configurations. Therefore, they combine with each other or with other atoms to attain stable electronic configuration. The tendency of atoms of various elements to attain stable configuration of 8 electrons in their valence shells is the cause of chemical combination, and the principle of attaining the maximum of 8 electrons in the valence shell is called the octet rule. Depending upon the number of shared electron pairs, the covalent bond can be classified into single covalent bond, double covalent bond, and triple covalent bond. A single bond is formed when only one pair of the electron is shared between the two participating atoms. It is represented by one dash. Although this form of covalent bond has a smaller density and is weaker than a double and triple bond, it is the most stable. For example, hydrochloric acid or HCl molecule has one hydrogen atom with 1 valence electron and one chlorine atom with 7 valence electrons. In this case, a single bond is formed between hydrogen and chlorine by sharing 1 electron. A double bond is formed when 2 pairs of electrons are shared between the two participating atoms. It is represented by 2 dashes. Double covalent bonds are much stronger than a single bond, but they are less stable. First example is the carbon dioxide molecule. It has one carbon atom with 4 valence electrons and 2 oxygen atoms with 6 valence electrons. To complete its octet, carbon shares 2 of its valence electrons with one oxygen atom and 2 with another oxygen atom. Each oxygen atom shares its 2 electrons with carbon, and therefore there are 2 double bonds in carbon dioxide. In the formation in the oxygen molecule, each oxygen atom has 6 electrons in their valence shell. Each atom requires 2 electrons more to complete their octet. Therefore, the atom shares 2 electrons each to form the oxygen molecule. Since 2 electron pairs are shared, there is a double bond between the 2 oxygen atoms. A triple bond is formed when 3 pairs of electrons are shared between the 2 participating atoms. Triple covalent bonds are represented by 3 dashes and are the least stable types of covalent bonds. In the formation of a nitrogen molecule, each nitrogen atoms having 5 valence electrons provides 3 electrons to form 3 electron pairs for sharing. Thus, a triple bond is formed between the 2 nitrogen atoms. A shared pair is a pair of valence electrons that is shared between atoms, while an unshared pair is a pair of valence electrons that is not shared between atoms. Based on the given example, there are 3 pairs of electrons in the outer level of nitrogen that are involved in bonding the hydrogens, and it's called the shared pairs. The other 1 pair of electrons which is not involved in bonding, it is called the unshared pairs. The following are the differences between ionic and covalent bonds. A covalent bond is formed between 2 similar electronegative nonmetals, while ionic bonds are formed between a metal and a nonmetal. Covalent bonds have definite shape, while ionic bonds do not have definite shape. Covalent bonds has low melting and boiling point, while ionic bonds has high melting and boiling point. Covalent bonds has low polarity and more flammable, while ionic bonds has high polarity and less flammable. Covalent bonds are in liquid or in gaseous state at room temperature, while ionic bonds are in solid state at room temperature. Thank you for watching. Do not forget to subscribe for more science educational videos by clicking the notification bell below.